Hey guys, this is Mr. DeGrow. In this video, we're going to talk about how to translate our expressions, or our English expression, into a mathematical expression. So there's a lot of words that you kind of need to know what their definition is mathematically. And I'm going to write down a quick list of the ones you're going to see the most in our class. It's not going to be absolutely every single one, and you have to really use your knowledge of the English language to really answer a lot of other things. The way you put these phrases together, sometimes one word could actually mean the exact opposite, depending on what you're looking at. It's all about the context of the problem and what you're thinking. So, some of the basic ones. So, this is the plus symbol, but you're not going to see the word plus very often. But if you did, you definitely better put plus in there, put an addition symbol in for it. But also there's sum. This is probably going to be the most likely one to come up. So if you see the sum of three numbers, that means you're going to add them all up. Sometimes you'll see the word total. And sometimes you'll just see the word add. So 3 is added to x, that means 3 plus x. Again, these are not the entire list of words, but especially with sum, these are the ones you're going to expect to see the most. Alright, so we have subtract, right? For our subtraction symbol. The other big ones you're going to see are difference, and you got to be a little careful about the next one. Less than. Anytime you see this, it actually gets flipped around. So if I ever said 5 less than x, that means x minus 5. So it's either less than or just less. So a variable less 3 would be x minus 3. It's like you're taking 3 less of it. So you got to be really careful. The than flips it around. So subtract, difference, less than, or less. All of these give us a subtraction symbol. And there's more. I'm not saying the entire list is just those. Alright, so for multiplication. So if you see the word multiply, I hope we would realize we put in a multiplication symbol. Most of the time in our class, we're not going to use this x too much because this is algebra and now x is a variable. So most of the time you're going to see multiplication as a dot or sometimes an asterisk, but not so much x's. Okay, so we're not using this symbol all that much. Alright, the big one for multiplication is product. So product is multiplication. Product of 5 and a number means 5 times x. You're going to use the dot. I don't even need to put the dot in here for something like this. It would just be 5x. That would be the product of 5 and a number. And the last one, division. Of course, if it says divide. The big one, there's two that you're going to see every once in a while. They don't come up quite as often. You're going to see product all the time. That's my star for this one. Less than is my star for this one. It's not that it comes up more often, it's the one you have to actually be the most worried about. It's kind of flipped around. So divide, quotient. This one's a little trickier. The quotient of 3 and a number would be 3 over x. 3 divided by x. Now you're not going to see, so for a lot of the times we divide, we're going to use like a slash, like a fraction bar idea. A fraction, 3 over 5 means 3 divided by 5. It means exactly the same thing. So when I say the quotient of 3 in a number, I could put 3 divided by x, but you're not really going to write that so much, especially if you look at our new calculators. You're going to use this symbol, not so much the division symbol. So they're both the same. And also, 3 over x is exactly the same thing. So same thing here, we don't really use this x anymore. We use a dot or a star. In class, we'll just use a dot. In division, we use the fraction mark. Alright, the other one that you'll see every once in a while. So quotient's the one that probably get the star because it comes up, but it doesn't make as much sense. Not just in your normal vocabulary. And the ratio. The ratio of a number to 2 would be x divided by 2. And that would go in the way you say them. The quotient of 3 in a number is 3 over the number. The ratio of a number to 2 would be a number over 2. Alright, before we move on, I thought of a couple extra ones. We need more. Or more than. Now you see that less than and more than, a lot of times it actually does switch things around, but when you're adding two numbers, 2 plus 3 is the same thing as 3 plus 2. That's not true for subtraction. 2 minus 3 would be negative 1. 3 minus 2 would be 1. So for more than, you don't really have to even worry about. And the other one that you'll see sometimes for multiplication is of. So for of, if I want to talk about, that's mainly going to go with percentages. So like 15% of something would be, well, you have to turn a percent into a decimal, so you move the decimal place over twice. So 0.15, 15% of something means times whatever you're looking at, like x. Okay, so adding 2 extra in here before we move on. So more than, it doesn't have to just be more than, it could also be just more. So more is an addition idea. I don't think we have to come back and add that one in here, but it comes up in the first problem below. So let's try to actually do a couple of these before we move on. Alright, so 8 more than a number. Now, the instructions say we're going to write an algebraic expression. So this is not an equation. When we go 8 more than a number, we're just going to go from left to right, 8 more than. Now, depending on how you read this more than, you're either going to write 8 plus a number n, or n plus 8. If it was less than, we would definitely go with the n plus 8. Now, if it just said a number without the n, you could use n, x, w, it doesn't really matter. So most of you are probably going to go with this first version, but when you go with less than, you really should be swinging the 8 over to the other side. So anytime you see that little than, we're going to try to write it in this order, where this and n switch places. Now, I said it's not an equation. If it was an equation, we would have equals something like 3, but there's no equals in this. It's just this expression. All right, let's try the next one. 7 less than, that's that than part. Product, talk about that being multiplication, right? 4 and a number. So the product of 4 and a number is 4 times x. Now, if it's 4 times x, I don't have to put the dot, and please don't do this, 4 times x, because that's just really weird. Okay, so less than. That means we're not doing 7 minus this. We are bringing the 7 over to the other side. Now, it's less than the product of 4 and a number. So these have to go together first, and then you're subtracting 7. It's less than this product. If it was 7 less than 4, and then the product of that, it would be 4 minus 7, and then multiply that by x. But you get to really read through these. Alright, why don't you try C on your own. Alright, so product is multiplication. So product of 7m to the 5th power. Now this you have to use a little bit of order of operations, and you have to do a little bit of reading with English. So the question is it 7 times m to the 5th power, or is it 7 times m to the 5th power? And that's a legitimate question, and it's really tricky to tell the difference between the two. So just think about, if I was going to read this out loud to you, this is the product of 7m to the 5th power. That's how I would say it. If I wanted to read 7 times m to the 5th power, I would have to say it as the 5th power of the product of 7 and m. That's how I would read this one. Alright, difference. Subtraction, 4x squared. So again, it's not, we have to be careful about what gets the difference. So difference is subtraction, 4 minus x squared, just x squared, that's it. If it was the difference of 4 and x, now here's the thing, you have to be like an English major. If the difference of 4 and x squared, that would be this version. So you got to be really, really careful how you read it. The difference of 4 and x squared means the difference of 4 and x squared. Alright, next one. Product 5 less than the product of 3 and a number. So products multiplication, this is a little bit easier. The last couple are a little tougher. 3 and a number, it doesn't say what we want to let the n be. So n, number n, x, doesn't matter. 5 less than, that's the one you want to subtract over your 5 afterwards because of the less than. Alright, sum of 3 different numbers. Why don't you take a second, pause this, and see if you can answer this, and then check your answer. Alright, hopefully you did that and not just sat there. So if you haven't paused it yet, pause it, because I'm going to give you the answer. Alright, 3 different numbers have to be x plus y plus z. The letters don't matter, but they can't be like x plus x plus x, because they're different numbers. If it was x plus x plus x, then there would be 3 of the same numbers, divided by 3. You would also write this way, x plus y plus z divided by 3. This is true, or this is true, but this is not good, because all that would be divided by 3 in this case is the z. So it would be the sum of two numbers, and the third number that's divided by 3 to get this expression. Alright, G, 15% of a bill, so 15%, you change that into decimal, you have to move the decimal place over twice, so it would be 0.15. We talked of being multiplication, so times a bill, whatever it is. This would be kind of a bad tip. Alright, 16 to 20% should be a good tip. Alright, and then try to work in the other direction. So, you want to write a verbal expression. I don't know how much I'm going to be writing this as just reading them out loud to you. So, our first example, this would be a product. So, 4 times m. You don't see the multiplication, but it's a product of 4. Should you write it out in words? 4 and m cubed, or raised to the third power. It doesn't really matter. So for B, it would be c squared, or sorry, the sum of c squared and the product of 21 and D. It's kind of, you just have to read it basically left to right. We're doing this, we're add these together. Now some people will cheat a little bit. C squared plus 21D, that kind of is okay. Same thing with D, you could say 4 times a number minus 11, but I would write the product of 4 and a number less 11. Other version would be 11 less than the product of 4 and a number. Any one of these answers is good. So you should try the rest of these and then check them when you get back to class. Let's take a quick look at the bottom of this. Is there anything else we need to do? Alright, let's do this. This is the last example real quick, and you should try to finish all the ones that I've skipped on your own. Used Bookstore sells paperback fiction books in excellent condition for $2.50 and in fair condition for 50 cents. Write an expression for the cost of buying E excellent condition paperback books and F fair condition paperback books. Okay, so it's $2.50 for all of the excellent, so we have to multiply that by the number of excellent paperback books. And then we're going to add the price of all of our fair condition books. So 0.5 for each of those times the number of fair condition books. So for instance, if you have one of each, you expect to pay $3. Plug in 1 for each of these numbers, and we've got it. Alright, if this is your first video, you should be going back through all the problems, making sure you understand what they're saying, what they're doing. You should finish out the ones that you haven't done yet, and check your answers for all of them once you get to class.